This is the first topic, kinetic particle theory. First thing, what does kinetic particle theory says? Now, kinetic particle theory says that all matter is made up of tiny particles that are in random and constant motion. Random means the motion is unpredictable, and constant means all the time. So the unpredictable motion is taking place all the time. That is basically what this kinetic particle theory is all about. Now, this word particles, it can mean atoms, it can mean molecules, it can mean ions. Depends on what kind of substance is it. Now, this table shows the properties of solid, liquid, and gas of all the states of matters in terms of the arrangement of particles, particle motion or the movement, attractive forces between the particles, as well as the kinetic energy of the particles. So kinetic energy would mean that how fast or how slow the particles move or vibrate. For example, solid, the vibration of the solid particles is actually very slow. Therefore, the particles in the solid have very low level of kinetic energy as compared to liquid and gases. Now let's look at the arrangement of particles for solid: orderly, closely packed; liquid, disorderly, less closely packed; and for gas would be highly disorderly and far apart. Now it is very important for you to remember all these descriptors. Very important. And this would be the particle diagram for solid, liquid, and gas. Now for solid, it's very important to draw the particles. So all the particles must be in a circle, in a round shape. And for solid, no space should exist between all the circles, and they must be orderly, packed very closely like this. For liquid, it's better not to draw the liquid particles to be behind. Okay, so it's better to draw liquid particles like this. Okay, some liquid particles would be very close to each other, some are very far apart. But most importantly is all the liquid particles must be of the same size. And then for gases, it is good to draw only 3 circles, and they should not be in any pattern. So for the gas particles, you should not draw like that, because this one has a pattern. You should not draw like this as well. Although they are far apart, but they are actually quite regular or quite orderly. They should be disorderly, no pattern. So these two are wrong. Okay, how about the particle motion or the movement? Vibrate is the keyword. For liquid, slide over each other, that is the keyword. And for gas, move freely and randomly. It's better to say move freely and randomly in all directions. Attractive forces. For solid, all the particles are strongly attracted to each other. That means the attractive forces between the particles are very strong. That's why they are all very close to each other. For liquid, it is just strong, and then for gas would be very weak, because all the particles are very far apart from each other. So the attractive forces, okay, the forces that attract them together, is very weak. Okay, so this table is extremely important. You have to memorize the keywords. Now let's go on to this, okay, whether the states of matters have the fixed shape, fixed volume, or can be compressed. This one should not be a problem. Now let's go to this question: why can gas be compressed? Okay, gas be compressed because gas particles are far apart from each other. When pressure is applied, gas particles are forced to become closer to each other, hence compressible. So for example, gas particles like this, okay, they are very far apart. If let's say I compress them, when I compress the gas, it is as if I make the container smaller. Okay, when I make the container smaller, still, I mean it's possible to make the container smaller. So when I make the container smaller, meaning that I apply a pressure. When I apply a pressure, the particles will be closer to each other. Okay, which means that gas particles or gas can be compressed. That is basically what it means here. Gas particles, they are far apart. When pressure is applied or when the container is made smaller, then the gas particles are forced to become closer to each other. Okay, so this is a typical kind of question that would be asked during O-level. Now let's look at this diagram here, the change of states when particles gain or lose energy. Now, something special here is on sublimation. So sublimation is a change of state from solid to gas. Gas to solid is called condensation. It's the same as gas to liquid. You see, gas to liquid is also called condensation. Gas to solid is also called condensation. Now, one example for this sublimation is dry ice. Dry ice or solid carbon dioxide. It is a solid, and when it is exposed to air, it will change from solid to gas. Okay. Now, when the solid change to gas or solid change to liquid, it involves gain of or absorb of heat energy. Okay, for example, from solid to gas, solid, all the solid particles are very close to each other. Now, in order to separate the solid particles from each other, we need to supply heat energy, so that we need to supply heat energy to overcome the attractive forces or to break the attractive forces between the solid particles. So when solid change to gas, we need to supply energy, which means that heat energy is absorbed. Likewise for solid to liquid. Solid particles again is very close to each other. Liquid, they are very far apart. So in order for solid, in order to break the solid particles, to split the solid particles apart, we need to supply them energy. We need to supply them energy, heat energy, so that the heat energy can be used to overcome the attractive forces between the solid particles, so that they are split and then they'll become liquid. Okay, so solid to liquid, gain of heat energy. Same thing for solid to gas, gain of heat energy. And the same thing for liquid to gas is also a gain of heat energy. So in this diagram you can see that all the red line means that heat energy is absorbed, and the blue line means heat energy is released. For example, gas to solid, gas particles, they have a lot of energy because they move freely in all directions very fast. Okay, gas particles have a lot of energy. Solid particles, they have less energy because they only vibrate in their fixed position. So in order to go from more energy to less energy, the energy must be released. Therefore, in order for a substance to change from gas to solid, energy must be released. The blue line here means energy must be released to the surrounding. Likewise for liquid to solid. Liquid compared to solid, liquid particles have more energy because liquid particles slide over each other. Solid particles only vibrate in their own position. So in order to go from something that have more energy to less energy, heat must be released. Okay, likewise for gas to liquid. So it's very important for you to know which change of states involve gain of heat energy or absorb of heat energy, which change of states involve release of heat energy. It's very important for you to know that. So basically what you need to do is you compare the two states, which one has more energy, and then in order for something to go from less to more energy, heat energy must be absorbed. Therefore in this sublimation process, heat energy is absorbed. Okay? Yeah. Now the next thing is volatile liquid. What do you mean by volatile liquid? So liquids that evaporate quickly at room temperature, they are called volatile liquid. So volatile liquid, usually they have low boiling point. Okay, volatile liquid, usually they have low boiling point. That means they boil very easily. It means that they turn into gas very easily. That is called volatile liquid. An example would be ethanol. The next part is on the differences between boiling and evaporation. So these are the differences between boiling and evaporation. Boiling only occurs at the boiling point. For example, water. Water only boils at one temperature, which is 100 degrees Celsius. But water evaporates at almost any temperature. Okay, at temperatures below boiling point. So any temperature below boiling point, evaporation would take place. Okay, evaporation can take place at room temperature 30 degrees Celsius. It can take place at slightly below room temperature, maybe like 20 degrees Celsius. So evaporation takes place at temperatures below boiling point. Which part of the liquid? Boiling throughout the liquid. When water boils, for example, the entire water would boil, but not for the evaporation. Evaporation only takes place at the surface of the liquid. At the surface of the liquid, because the surface of the liquid is exposed to the atmosphere. And the speed, boiling is very fast, evaporation is very slow. Okay, this part I don't think I need to go through it. It's quite self-explanatory. Okay, as well as this. So when heated, kinetic particles gain kinetic energy and move faster. So let's say when a gas is or when the liquid is heated, the particles have enough energy to overcome the attractive forces between the particles, and the particles spread far apart and the substance becomes a gas. So this one involves boiling. When you heat a liquid and then when it boils, what happened to it? Now let's look at this. So this is the apparatus to determine the boiling point of a solid, the melting point of a solid. Okay, in this case, naphthalene, which is mothball. Okay, mothball, you crush it, and then if we want to determine the melting point of a mothball, this is what we do. We put it in a test tube, and then the thermometer is dipped inside the mothball, and then after that, this whole test tube is put in a water bath. In a beaker filled with water. Then after that, what we do is we heat the water. When the water boils, then the temperature the temperature of the naphthalene would increase as well. Then slowly the naphthalene would melt. Okay, this whole apparatus is to determine the melting point of a solid, any solid. Now, why is naphthalene not heated directly with Bunsen burner in this experiment? Is because it is more flammable. Also, the reason that it is heated in a water bath is to ensure slow and even heating. Because when mothball or when the naphthalene is heated by the fire directly, the increase in temperature will be very fast. And when the increase in temperature is very fast, it makes recording of the temperature increase very, very difficult and inaccurate. Therefore, we need to heat it in a water bath like this. Okay, and you have to always ensure that the water level is above the naphthalene level. Now, this is a heating curve. Okay, when you see something increase, then flatten, then become horizontal, then after that increase again. So this one is a heating curve, very important heating curve. Now in this heating curve basically the y-axis is the temperature, the x-axis is the time. So what we do is we heat a substance, and then we take the time and take the temperature at the same time. Then after that we plot the graph out. So this temperature, the starting temperature, is always the room temperature. Okay, now so this is a heating curve of naphthalene, of the mothball. Now as the mothball is increased, what happened? The temperature, as the mothball is heated, what happened to the heating curve? What happened to the temperature? The temperature of the solid naphthalene increases until it reaches point B. So point B would be the melting point. For naphthalene, it would be about 80 degrees Celsius. Okay, so at point B, solid naphthalene begins to melt and change into liquid. So from B to C, it's actually a mixture of solid and liquid. At this point, solid naphthalene starts to melt. Now from A to B, there is an increase in temperature. Why? Because the heat provided, the heat supplied to the naphthalene is used to increase the kinetic energy of the particles. So whenever there is an increase in the kinetic energy of particles, the temperature will increase. Okay, so this note here, temperature increases only when there is an increase in the kinetic energy of particles. Over here, you can see that the temperature doesn't increase. So if the temperature doesn't increase, even though heat is provided, it means that the kinetic energy of the particles doesn't increase. So the heat provided is not used to increase the kinetic energy of the particles. So what does the heat provided being used? The heat provided being used is, the heat provided is being used to overcome the attractive forces between the particles. In order to in order to change solid to liquid, you need to break the attractive forces between the particles first. Okay? Therefore, the heat, so from B to C, there is no increase in the temperature, and the heat provided is used to overcome the attractive forces between the particles. So from B to C, the heat provided is not used to increase the kinetic energy of the particles. That means from B to C, the vibration or the movement of the particles, the speed of the motion or the speed of vibration of the particles do not change from B to C. Okay, from B to C, temperature remain constant. Okay, until all the solid becomes liquid. So only at this point, only at point C, all the solid naphthalene would have changed to liquid naphthalene, and only at this point onwards, the temperature will increase. So only at this point onwards, the heat energy provided is used to increase the kinetic energy of the particles from C to D. Okay, so it's very important to note that temperature increases only when there is an increase in kinetic energy of the particles, which means that from B to C, no increase in the kinetic energy of the particles. From C to D, there is an increase in the kinetic energy of the particles, as well as from A to B. And you need to understand, why isn't there an increase in the kinetic energy of the particles even though heat is provided? Because the heat provided is used for something else, which is to overcome the attractive forces between the particles.